A Ferrari is expensive, but beneath some of the largest mining trucks on Earth, there is something even more valuable: 6 tires. Together, a set of giant mining tires can cost hundreds of thousands of dollars, more than some brand new Ferraris. And at first, the reason seems obvious. They are enormous. A tire in the 59/80R63 class can stand roughly 4 meters tall. It can weigh around 5 tons, and 6 of them must carry a machine that, fully loaded, can weigh well over 500,000 kilograms. But size is not the real reason these tires are extraordinary, because deep inside every one of them, a battle is taking place. A battle against heat. Consider a Caterpillar 797F. It can carry roughly 400 tons of payload. Its engine produces around 4,000 horsepower. Everything about the machine seems designed around one idea: move an enormous amount of material as quickly as possible. But all of that power eventually reaches the ground through just 6 tires. And unlike steel wheels, those tires are constantly changing shape. As a loaded tire rolls forward, the rubber entering the contact patch is compressed and deformed. Then it recovers. Then it deforms again, over and over and over. But rubber does not return all of that energy. Some of it becomes heat. And when the tire is carrying tens of tons while repeating this cycle kilometer after kilometer, that heat begins to matter. A lot. Mining engineers have a number for this: TKPH, ton kilometers per hour. In simple terms, it connects 2 things that determine how hard a mining tire is being worked, how much weight it carries, and how fast that weight is being transported. Increase the load, and the tire works harder. Increase the average speed, and it works harder again. Eventually, the heat being generated inside the tire can become greater than the tire was designed to tolerate. And that creates a strange limit. Because the truck itself may still be capable of going faster. The engine has enough power. The transmission can keep working. The road may be clear. Production wants another load. But the tires may say no. This is where one of the largest machines on Earth becomes strangely vulnerable. Mining tires have rated TKPH limits, and those limits can influence how a haul road is operated. If the thermal demand becomes too high, operators may have to reduce the load, reduce average speed, change the operating cycle, or give the tires time to cool. There are even mine planning systems capable of introducing a TKPH delay into a truck's cycle when the thermal limit is exceeded. Think about what that means. A machine with thousands of horsepower, capable of moving hundreds of tons at a time, can effectively be forced to wait for its tires to cool down. And the hotter the mine becomes, the more difficult the problem can become. Ambient temperature itself is part of the calculation. A haul cycle that works safely under one set of conditions may place greater thermal stress on the same tire when the environment becomes hotter. But engineers face another problem. They cannot simply build the hardest tire possible. Mining roads can be brutal. Sharp rocks cut rubber. Rough surfaces tear tread. Heavy loads accelerate wear. So a tire compound can be designed to resist cuts and abrasion. But there is a trade-off. Compounds optimized for extreme resistance to cuts and wear generally do not offer the same TKPH capability as compounds optimized to handle heat. So the mine must choose. A tire designed to survive aggressive rock, or one capable of tolerating greater thermal workload. There is no perfect tire. There is only the right compromise for a particular mine. And suddenly, the extraordinary price begins to make more sense. This is not simply a giant piece of rubber. A single ultra-class mining tire is a massive engineered structure containing tons of specialized rubber compounds, steel reinforcement, and carefully designed layers. Its job is not merely to support the truck. It must survive enormous loads, violent terrain, continuous deformation, abrasion, cuts, pressure, and heat for thousands of operating hours. And because these tires are so valuable, damage does not necessarily mean the end. Specialized facilities can repair enormous cuts and injuries. Some casings can be retreaded. A tire worth tens of thousands of dollars may be rebuilt and sent back into the mine for another working life. Even changing one is an operation of its own. You do not roll a 5-ton tire across a workshop by hand. Specialized tire handlers grip and manipulate it while technicians work around a machine several meters high. Depending on the operation and the tire position, a change can consume hours of valuable truck availability. And while the truck is standing still, it is carrying nothing.